Representing motion. Last time the essential question was, how do we communicate an object's motion? For this lesson, it's going to be the same essential question, but we're going to add a little bit more to it. So, how do we communicate an object's motion so we can make predictions? Through this lesson, we're going to be able to interpret the motion of an object from a table, and we'll be able to interpret the motion of an object from a motion diagram. We'll also be able to write an equation of motion, interpret one, and use one to predict future motion. And we'll be able to create or interpret a graph of motion and change from one type of graph to another to show the same motion. Here's our vocabulary preview. Remember, you're not going to understand all of this, and if you do understand all of these words, does not mean you understand all of the material. These words will be used throughout this lesson. Motion diagram, a number line showing dots alongside it, where each dot represents the position of the moving object at a certain time. Slope of a graph is the ratio of the graph's vertical change to the horizontal change. Rise over run. Area of the graph. The area is defined by the graph, the horizontal axis, and two vertical lines called initial and final. To find the area of a graph, or area under a curve, you're multiplying the y-axis by the x-axis. Why do we care? Last time we discussed how we communicate motions. With our communications, we can explain what happened when an object moved. Physics is about more than what happened. Specifically, physics is about communicating what happened, or is happening, and being able to predict what will happen. People pay frauds with crystal balls lots of money to predict the future. You, as a physicist, will use science to actually predict the future.